Hello listeners, today we will learn about the factors in which moment of inertia depends. In the last class we have discussed about the moment of inertia of different mass distribution, like for single mass and single particle mass and number of particles, and also we have discussed about the moment of inertia of rigid bodies. So in this class we will discuss that the factors on which moment of inertia depends. So number one factor is the mass distribution of particles, or we can say in rigid bodies. So mass distribution of particle, or we can say that this mass distribution, the moment of inertia mainly depends. Let's take one example. Suppose there is axis of rotation, we have axis of rotation, and there are a number of masses, such as there is a m1 mass, so m1 mass, and this radius of rotation is r1, and there is a m2 mass, suppose this have r2 radius of rotation, and also there is m3 mass which is r3 radius of rotation. So if we take another axis of rotation, same axis of rotation having same position and same orientation, and but the mass distribution is different, like just take like there is a m1 mass, and the radius of rotation is r1, and there is a m2 mass, and there is a radius of rotation is r2, and suppose there is a m3 mass and radius of rotation is r3. So distribution of mass is different, and this system is rotating about this axis of rotation. Okay, so if you will find the moment of inertia about this axis, you will get I1 suppose, and you get I2 about this axis of this system. So if you find and will evaluate, then you will get that I1 will be not equals to I2. So if the mass distribution about the axis of rotation is different, you will get different moment of inertia. So the second factor is that the shape and size of the body. So we have talked about like moment of inertia of rigid bodies. So let's take different shape and size of rigid bodies. So I am taking one like rectangular lamina, and one more I am taking that circular disc like this. Okay, circular disc, and it is this shape. So this is the shape of circular disc. Okay, and both are rotating about this axis, and one more this axis. So axis is same, orientation is same. Suppose it is z axis, and it is rotating. This disc and this rectangular lamina is rotating about this axis of rotation. So this axis of rotation, and you will find, if you will find the moment of inertia about this axis, and about this body of this body about this axis, and of this circular disc about this axis, you suppose get I1 and I2. You will find that I1 will be not equals to I2. So it depends on the shape and size of the bodies. It is a circular disc, the orientation and the position of the axis of rotation is same. However, the moment of inertia of this circular disc will be not equals to the moment of inertia of that rectangular disc. So shape and size is an important factor on which moment of inertia depends. So third factor is that the position of the axis of rotation. So position of axis of rotation. So basically I am taking again this circular disc. Okay, and suppose this is a circular disc, and it is rotating about, like suppose there is a circular disc and it is rotating about this axis of rotation. You find the moment of inertia is I2. Here is I2. Suppose that is I2. That moment of inertia is I2. So again you again changes the axis of rotation, and this axis of rotation you take about this passing through the circumference. and the body is rotating about this axis of rotation. So you get that moment of inertia about this axis of rotation is I2 dash. Okay, so you will find that I2 will be not equals to I2 dash. Okay, so the moment of inertia depends on the position of the axis of rotation. You have taken this axis of rotation as passing through the center, and this blue one you are taking that this axis of rotation is passing through the circumference. So you will get different moment of inertia. The fourth and the last factor is that orientation of the axis of rotation. Okay, orientation of axis of rotation. So suppose again I am taking a like circular disc, and suppose this circular disc is rotating, okay, about this axis. Okay, this is z axis. Suppose this is z axis and it is rotating about this axis. So you find that moment of inertia is, suppose this about this axis of rotation, you find that Iz, or I2 you can take Iz. So if we change the orientation of this axis, suppose I am taking one more axis that that is passing through the x-axis, and the body is rotating about this axis. Suppose if the body will rotate about this axis, and you find that the moment of inertia about this axis is Ix, you will get that Ix will be not equals to Iz. So moment of inertia also depends upon the orientation of the axis of rotation. If a body rotates about z-axis, you will get different moment of inertia, and about x-axis you will get different moment of inertia. May or may not be, but it depends on the axis of rotation. If axis of rotation is changed, then there is a chance that moment of inertia will be different for that axis of rotation compared to the other axis of rotation. So these are the factors about which moment of inertia depends. In the next class we have discussed will discuss about the moment of inertia of different rigid bodies like circular disc, or and like about rectangular laminas and spheres. So we will discuss about that. Thank you.